Okay. Yeah, with this, I'm just going to talk about Ganeti. First, a little bit about me. I already had my brief introduction, but I'm a system administrator at Mozilla. I'm a contributor to the Ganeti project and a lot of sub-projects, or projects that are based around it, Ganglia, Gentoo, Phoronix, some others. So as a brief overview for Ganeti, it's self-described on its homepage as a cluster virtual server management software tool, which sounds like a lot, but when you actually look at what it does and what kind of role that it plays, it's a lot simpler, and I can show you with a live demo later. It's an open source project. It's hosted on Google Code. It's used actually a lot outside of Google as well. And it's used internally at Google, although to what extent I can't really say. What does it do? It's strictly management software. It doesn't actually do any of the heavy lifting itself. It manages replication and high availability of all the virtual machines that it's managing. And in this, it creates kind of a more scalable and more enterprise solution for people who need their virtual machines to have higher uptime or higher availability. Yeah, like I said before, it relies on the existing software to do all the heavy lifting. They didn't want to remake code to do things like disk replication. They didn't want to redo code. They didn't want to redo an entire hypervisor or anything else. And so these are some of the software that it uses. It uses KVM or Xen. It uses DRBD for the disk replication, and it uses LVM for the volume management and disk partitioning. But LVM didn't really have a logo, so I gave it one. As soon as they have one, they don't deserve Comic Sans. So, comparisons to some existing solutions like ESX are that you don't need a dedicated management machine for this. There's no vConsole, there's no vServer. You don't need to have Windows anywhere in your infrastructure for it, which is really nice. There's no SAN necessary for redundancy. With ESX, you need an approved SAN, which means you got to go knock on NetApp Store, and that means you get to spend mid to high 5 figures for it, which is just not an acceptable solution if you're a small company or you need to do this on the cheap. It's open source and freely deployable, which is great because it means that you can deploy it with Puppet and you can provision systems whenever you need to. And it means that the total cost for all of this is just hardware plus your time, which can be a lot less than just licensing a bunch of software. And it fits natively into your infrastructure. So if you're a RHEL shop, it runs perfectly in RHEL. If you're a Debian or Ubuntu shop, it runs there too. And so you don't need to have one-offs for your virtualization stuff. RMS would be proud. Some of the core concepts for this, I guess some of the definitions or words that are used with it. Cluster is exactly what you think it is. It's just a group of nodes. For the master, it's got a concept of a master and then a candidate master in case that master fails. And the master is responsible for making decisions on behalf of the entire cluster. And so you can do this to avoid things like split brain behavior or having two completely independent clusters if you lose network connectivity between two sets of hosts. Node is kind of a physical machine. That's what you think of as like a one-use server that's part of your cluster. And with Ganeti, you have the concepts of primary and secondary nodes. With a primary node is the node that the virtual machine runs on, and the secondary node is where you're replicating the disks in case of the failure of the primary machine. An instance is the term they use just for a simple virtual machine. And a job is just a single operation. All jobs submitted to Ganeti run through a standard job queue. So this way you have a nice timeline of operations and you can queue them up and do them in bulk and whatever else you need to do. There's also an instance type. So let's say you have your virtual machines. How do you want to install them? How do you want to provision them? Do you kickstart them? Do you just deploy with a template image, which can be as simple as a tarball? Or do you use something like dbootstrap or RPM strap to roll it and make sure that it's up to date right away? This is sort of the schema for a generic cluster. In this, there's only 3 nodes, but you can scale it, and the optimal size is about 40 nodes. Tier is just you administering from your laptop. You have your 3 nodes, and then the solid lines are, the text is a little small, you can't see it, but the solid lines are the primary node that the instance is running on, and the secondary node is noted by the dotted line. And one thing I should mention, it can get a lot more complicated than this. You can have back-end network links between the nodes. That way, your DRBD traffic isn't exposed to a network switch, which can be a major security mistake, depending on your network. Redundancy, DRBD provides network RAID 1, and that way even if your nodes don't have RAID, you still have redundancy. It's just over the network and abstracted from it. And that means that you can do it a lot cheaper, or if you want RAID on your hardware, you can have multiple levels of RAID and do it that way anyways. But with this, it avoids a lot of downtime if you do have a disk failure over RAID, or if you even have a host failure, which can be even worse. It uses LVM snapshotting for backups, and that means that it can do nice things like do it online, do it with copy over write, or copy on write, and that sort of thing. And it provides live migration and failover capacity, and so if you know that, which is really nice, because if you know that you want to do a hardware upgrade or you have downtime on a particular rack because you need to do some network things, then you can migrate your virtual machines without interruption over, do your work, and then like upgrade RAM or something, and then migrate all of your instances back without losing any uptime. It also has a concept of I allocators, which automatically balance the cluster and make sure that you're not overloading one node with virtual machines. It'll keep that nice and balanced, and even includes tools to balance it later without interrupting service. So installation is fairly easy with this. Like I said, it uses LVM, so the first step is just to create a volume group for it. And then you install it using apt or yum or Gentoo or whatever you like. And then after you do that on every node, or your first node, you can do this with just one node as well. You initialize a cluster, you pass it some parameters, and then it's good to go. And so once you've done this, there are kind of 2 administration modes that you can use for this, depending on if you're a hardcore command line user, and if not, then you have a web manager to do all this for you. And the web manager also provides some pretty compelling features past what the command line is capable of. I just have some examples of commands here. It's split into basically 5 different commands. And the Ganeti cluster command is used for all cluster-specific operations that you'd like to do. Like, for instance, in this slide, we can see that it's doing a verify across the entire cluster and making sure that all of the disks are replicated, all of the instances that are supposed to be online are online, and it's also checking that if there's a node failure, that the rest of the cluster will be able to accommodate all the virtual machines, or all the instances that we're running on there. Ganeti node is for node operations. This is a simple one called list, and it shows you the available resources on everything else in the cluster. You can see memory free, disk free, and how many primary instances are running on each node, and secondaries. Ganeti instance is how you interact with instances, whether you want to go into them using a virtual serial console, whether you want to get the info and then VNC into them yourself, if you want to adjust the network configuration on it to put it on a different bridge in VLAN, this is how you do it. Or to create or remove VMs instances. The backup, this is a nice backup solution because it just exports them with a raw disk dump and then a metadata file, so you can use this, and there are scripts to migrate them between clusters, which is nice. Or if you just want to use this as a backup, you can keep this on a remote data store and then restore it as you need. And with this, I'm shutting the instance down to do an offline capture, but you can do this online as well. G&T job, like I said before, it has the concept of a queue system, and so you can list them, you can see which jobs are running and which jobs are still waiting to be run, and you can even go into previous jobs that have executed and see the detailed output of it to see if it succeeded or failed, and to see the actual console log for it. Now I'd like to demo Ganeti Web Manager for you to show you how powerful and cool it is. So let me log out and I'll log back in. So this is just a standard login page. You can tie it with LDAP, or you can do a basic authentication. It's built on Django and uses the permission model from that. So you can have a local database or LDAP. So I'll log in as my single user called root, and we're presented with an overview of all of the clusters I have in here and some status of things that are relevant to me. So one of the nice things about Ganeti Web Manager is that it can handle more than one cluster. For instance, I just have my cluster here called Ganeti, but I could just as easily add more clusters if I need to. I can click on clusters and then click add cluster, and then it's got a remote API that I can then connect to and administer. Also here, let me click on this cluster so we can get a slightly more detailed view of it. Here we can see some metadata about it. We can see it's 64-bit. We're using the KVM hypervisor, how many virtual machines are run on it, and that sort of thing. We can also see how much how many resources are being used, and we can even set quotas for different users for it, which is very convenient. We can also click edit, and we can edit some information on it. We can set our default quota, we can edit the host name, description, some pretty basic stuff. Afterwards, we can go, there's tabs at the top here. One is called Virtual Machines, and we can see that I just have one virtual machine right now, which is running this web interface that we're using. And so I can click on it and get a bunch of information about its statistics. So we can see here that it's using ACPI, it's just booting to a standard disk. Really, these are just things that you'd want to set for your environment, but here they're pretty simple defaults. I haven't changed anything. And in here, we can do things like edit it. We can give it more RAM, we can give it more disk space, we can give it different arguments. And we can also do a live migration and migrate it to its secondary, which we can see is the Ganeti 3 node. But right now, what I want to show you is we don't have any users, we don't actually need them, they're optional. And we have a log of all the operations done to it. And we also have the console here, which is really convenient and beats the hell out of RDPing to a Windows box just so you can get a console on your VMware VMs. So we can go click connect, and now I have this nice JavaScript console for my virtual machine. And we can have multiple users doing this at the same time. It's done securely. And it's all done in JavaScript. There's no Flash anywhere about. It uses WebSockets for the presentation of it and to establish the connections. And so the next thing I'd like to show you is once I go back to my cluster, I can add a virtual machine over here. And it can be as simple or as complicated as I want. I can set my owner, which cluster, which hypervisor I want it to use. And so I'll just call this one my test VM3. And over here we can see there's a nice big box for a tooltip over here, and that has information relevant to all of these different fields. So I can say DNS name check. I don't want to do that because I don't actually have DNS running on my laptop. And now I can see use with caution. You may run into name and IP collisions on here. We can tell it we want a DRBD disk template because we want it to be replicated. And we're going to use Oneric, which is the distribution that I have preloaded on my laptop. We can say we want it to run 128 megabytes of RAM and give it a 2 gigabyte disk. And then I click create. And now there's a failure. It wouldn't be a demo without breaking everything, would it? Let me try that one more time. Okay, well that's disappointing, but I can show you some of the command line stuff, what it would have looked like, and we can see the job that it tried to execute. Which is number 342. At the bottom, I don't know if you can see that in the back row. Oh, it's already in the cluster. That would be why. So we'll just name it 4. Oh, what's the error now? I think I'll just not do that part and continue on. I can verify different parts of the cluster. Like you saw before with all of my, my slides with command line arguments in them, I can do them live from here too. I have all 3 of these virtual machines that are the nodes running on my laptop, and I'm running virtual machines inside of those for this demo. And sometimes that's a little less than stable. Okay, let me just go back to my presentation. We're about done with it. Next, there's the concept of HTools, which is it's a package that's also distributed alongside Ganeti, although it's by no means canonical. It's got 3 basic tools that it uses. Hail is the intelligent allocator that is used at VM creation time, or instance creation time. And that decides which nodes are the freest, and it will it'll assign the freest as primary and second freest as secondary. HBAL is the auto balancer, and you can run it on an existing cluster, and it will optimize the resource usage between all of the nodes. And that way, like I explained earlier, you don't have one node that's completely overloaded while the rest are remaining idle. And HSpace is used for capacity planning, and it will give you things like you can specify what your default VM size is, how much RAM it has, how many or what size disks it has, how many virtual CPUs, and then it will tell you how many of those instances you can accommodate on your existing hardware, and then it will tell you the failure reason or which resource is going to run out first, which is really convenient if you need to grow your cluster size, because then you can tell your boss you need more RAM for your nodes, or you just need more nodes overall because you ran out of CPUs. There's also Puppet modules. I have a Puppet module called Puppet-Ganeti up on my GitHub page. We use it internally at Mozilla for this. It's convenient. We use it for deploying it. It runs on RHEL, and it also runs on Debian-based derivatives, so Debian and Ubuntu. I also have the Ganeti Web Manager as a subclass or a submodule of this in case you want to deploy that. And with the convenient thing about the Ganeti Web Manager is you can have it run in a remote location, because the API that it uses can be run on or targeted to remote hosts. It doesn't even have to be in the same data center as it. The future for it, right now it only supports KVM and Xen. LXC and containers are in the future for it. That should be actually in the next point release, which should be out in about a month. And that's also, that point release has a bunch of features that are also listed here, like the live migration with file-based storage. Right now, the only way that it supports live migration is when you use replicated DRBD storage. Also, there's the concept of multiple secondaries, so if you have really critical instances, such as name servers running on it that you really don't want to go down, you could have triple replication if you need to. Also, there's a concept of eliminating secondaries that's it's not set for the next point release, but it is on the roadmap for the 2.6 series. Right now we're at 2.4. Elimination of secondaries means that we'll be able to do things like have how ESX is currently, where you can migrate to different nodes in the cluster and not have to worry about primaries or secondaries. The problem with that is you also need a common data store for them, like an expensive SAN. But if you have an expensive SAN, it's a solution. You can find my work. My blog is blueheaven.ws, and all of the code that I've showed you is published at github.com/bcaro. That's the end. Are there any questions?
You say you don't need a SAN.
Can you wait, please, so the microphone arrives? Because the audience on the other side can't hear you.
You say it doesn't need a SAN. Can it work with a SAN?
It can work with a SAN, yes. Where I showed you where I selected DRBD-based storage when creating instances, you can also specify raw files, so you can specify a file path, so you can have an NFS-man or something like that. And additionally, you can also have raw LVM volumes, except it's rather hard to share raw LVM volumes between nodes.
So it can't point directly to an iSCSI LUN or something like that?
Right now, no. Right now, it's limited to a single volume group.
You've still
Any more
got
questions?
20-25 minutes.
I can try.
You can do the demo.
Okay.
Take questions.
Show us how easy it is to fix bugs.
I will just do it from the command line. Okay. And now I specify, it's got some options that you specify. So I'll specify the intelligent allocator because I don't care where it goes. I can say no IP check and no name check since I don't care about either. I can say my OS type is dbootstrap plus Honoric. Oh, yeah. Let me try enlarging the font here so you can see what I'm doing. I can say the disk type is DRBD. The size should be 2 gigs. And I'll give it 128 megs of RAM. And invariably, I will forget a single parameter. No, okay, cool. So it's actually going and we can watch it add it to the cluster. So it's got a sort of a live feed that we can see here for how the creation is going. Right now it's at the step where it's replicating the DRBD disk. We don't actually have to wait for this. If I submitted a no wait for sync option, it would just start the OS install right away and wait for eventual consistency. So we can see right here that it said it's putting it on Ganeti 1 as the primary node, which is the machine that this is currently running on. So I can Control-C it because it's a job that's going to run in the background. And indeed, if I look at the job list, I can see that it's currently running. And I can also do watch and then the number to watch it again. But I don't care because I know it's not gonna take an hour and a half. It just starts that way because it's replicating DRBD between 2 virtual machines on my laptop. But if I look in proc DRBD, I can get a little more information so I can see that it's 25% done and the speed it's going at, which is depressingly slow. One other thing I can demo, so we can see the G&T instance list here. I can see that I have my web manager VM running, and if I want to, I can go into the virtual console on it and wait for it to establish and hit enter, and now I have a console and I can log in. And this is really helpful if you're running a bunch of virtual machines and one of them goes down or you need to debug it, because you can do this just over SSH, which is really convenient. I can also get a bunch of information about the virtual machine, so I can do things like VNC into it if that's moreover what I want. This is also capable of doing manual install, so you don't actually need an existing disk. You don't need to use dbootstrap or anything else. What you can do is, right here we have the CD-ROM image path, and we can tell that we want a Windows ISO or FreeBSD ISO. And then we can boot that and then create the VM and then unmount the CD-ROM. And then doing that, you can have any operating system on there you want. One of the cool things about this as well is, okay, let me go again and see if I can find the network section. We can also assign multiple disks to it and multiple network cards. So here we can see I just have disk 0, it's 6 gigabytes. We can see some information on it if we need to go fix it. And here we can see that it's just got one NIC with a randomly generated MAC address and on my standard bridge. One of the cool things about doing all of this using just standard software that you'd otherwise find in the Linux stack is it allows you to use all of the skills that you've developed debugging software on this. So if you find really crazy issues with it, you can start S-tracing components in case it ever came to that. Additionally, if you don't know about KVM, it's a hypervisor built into the Linux kernel, and it allows us to do really convenient things, or it allows us to do convenient things, and it also means that we don't have to have a nasty hypervisor just kind of sitting on top. It's just part of the standard kernel, and all of your virtual machines will appear as processes. So that's inside a virtual machine. Now let me go to my actual laptop here and run htop, and we can see these 4 KVM processes for the virtual machines that I have running. So I can do some crazy things if I need to, like hit S to start S-tracing it, and I can't because it's owned by root. But yeah, if I need to do that, the option is there. Are there any other questions or things you guys want to see?
Can you do thin provisioning on the disks?
Thin provisioning on the disk, you mean like ballooning it? Oh, right, okay. So thin provisioning, as I understand it, is like allocating it 200 gigabytes and then have it not actually use have it not actually use 200 gigabytes until you actually allocate it. No, unfortunately not. Right now, well, I take that back. With a file type, you can have any file type that's supported by your hypervisor. So with KVM, that means you can have QED or Q copy on write to, and those are compression and do support thin provisioning. So if you're using a standard file-based data store for it, then you can.
Apologies if you already covered this, but what's it written in? I'm just wondering.
Oh, it's all Python. The entire thing is just pure Python.
Okay. So is the web interface interacting directly with the stuff like via APIs? Like, can I hook into it with my own,
yes,
my own stuff and put it in part of our systems sort of thing without having to actually use your web interface or the command line tools you provide?
Right. So the web interface actually just uses, the question is, does it use a standard API for it? And the answer is yes. Ganeti exposes a standard API that runs on a port, and if I run netstat, I can see that it's listening on port, I believe it's 5080. And that has a basic authentication mechanism on it, and then once that's established, then you have read-only or read-write control over the cluster through it. And both parts are just written in Python. The Ganeti Web Manager is written as Django, and this is actually just custom written Python.
What's the request like JSON request?
Yeah, right. Everything in it is JSON. So all of the batch jobs that you can submit are in JSON, and all of the APIs in JSON as well.
How is it different from libvirt, libvirt tools, or is this actually using the libvirt interface?
For deboot, like deboot?
The Ganeti complete interface, is it like, does it use libvirt?
Oh, no. Mm-hmm. No, it doesn't actually touch any part of libvirt at all. This interfaces directly with KVM. So I can see here I have one KVM process. There's no libvirt at all. libvirt, when the project started, libvirt had some rather inconvenient things, like it didn't support virt.io for disks, and it didn't handle the live migration in a completely sane way. And it was decided when the project started that they would not be using libvirt and instead just be talking to the raw hypervisors. Okay.
Yeah.
Oh, sorry.
If you already have an existing Zen cluster, can you install Ganeti and make it aware of an existing instances in a cluster?
Sort of. There are scripts out there that will migrate an existing Zen cluster into it. So before I started working at Mozilla, I worked at the open source lab implementing this there. And the previous virtualization cluster that we had there was completely Zen, and all of the machines were mounted over iSCSI. And if you look at the Open Source Lab blog, there's a blog post with scripts and other things to sort of import the existing machines into it. Did that answer your question? Yes. Okay. Just got the mic?
No, it answered my question as well.
Okay, cool.
I noticed in your example, to do a backup of an instance, you shut it down before taking the LVM snapshot.
Right.
Is it possible for Ganeti to communicate with the hypervisor to quiesce IO in the guest to be able to take a live backup of an instance?
Right. Yes, it is. Ganeti will, in at least the case of KVM, which is what my experience is with, this might not be true with Zen, but it does interface with KVM has a control socket, and you can issue commands to it like pause. And one of the things it can do, and it will do, is if you tell it to do a live snapshot, it will literally pause the it will start a snapshot and then pause the VM to get the last bit of the snapshot, and then unpause it.
You showed the JavaScript interface to the console, but it only showed text. Can it do graphics?
Yes, it can do graphics. If I go to the website, because I don't actually have a virtual machine with graphics on it now, one of the screenshots in there is of an Ubuntu VM with graphics, and it's got full cursor support and everything else in it. So there's a screenshot with graphics. Sure.
Monitoring these systems, how what's it's got for monitoring availability, etc.
Monitoring, as we've done it at Mozilla, is done on a per component basis. And so we have some monitoring for the overall health of the cluster, and we have that run probably every 20 minutes to make sure that none of the nodes are out of replication or anything else. But we also do things like we monitor the proc.drbd file and make sure that there are no inconsistent devices in there.
Do you have anything
Okay.
to say?
That's all the questions, and thank you for your time, and I hope you enjoyed my presentation.
Okay, as usual, on behalf of LCA team this year, I want to thank you for your good talk.
Okay, thank you.